Hello everyone. In this video, we're going to be going over the bubble sort algorithm. So first of all, keep in mind that this is not a very efficient sorting algorithm, and in the worst case time scenario, it would take O of n squared to run. So that's pretty slow. But the idea behind bubble sort is that we want to iterate through the array and swap consecutive elements that are not in order. So for example, we have this array with the elements 4, 7, 9, 5, 3, 11, and -2. So we're going to iterate through the array and basically swap the elements that are out of order. So 4 and 7 are in order, so we'll just keep those the same. Then the next consecutive elements are 7 and 9, which are still in order, so we'll keep that the same. Then 9 and 5 are out of order, so we would swap those. 9 and 3 are also out of order, so we would swap those. 9 and 11 are in order, so we'll keep that the same. And then 11 and -2 are out of order, so we'll swap that. And so this is our first pass with the bubble sort. Okay, let's do this again. So 4 and 7 are in order, 7 and 5 are out of order, 7 and 3 are out of order, 7 and 9 are in order, 9 and -2 are out of order, 9 and 11 are in order. So this would be the second pass. So for the third one, 4 and 5 are in order, 5 and 3 are out of order, 5 and 7 are in order, 7 and -2 are out of order, 7 and 9 are in order, and same with 9 and 11. So that's our third pass. So one important thing to observe with the bubble sort is that in the first pass, the 11 was moved to its right place. So the greatest element was moved to its right position. In the second pass, the second greatest element was moved in its right position, and so on. In the third pass, the third highest was moved into its right position, and we can kind of just observe this pattern. And so basically, with each pass of the bubble sort algorithm, the next highest element returns to its right position. So the next highest element is always bubbling up to the top in the next pass. At the same time, we can see that this took us 6 passes to completely sort, and we have 7 elements. So in the worst case scenario, when the array is completely unsorted, the runtime would be O of n squared. And the reason why is because we would have to do n passes. And then remember that in each pass, we're iterating through every single element. So that's why the runtime would be O of n squared. And in the best case scenario, where all the elements of the array are already in sorted order, the runtime would be O of n, because we would only have to do one pass to check if everything's sorted. So let's move on to the pseudocode for this algorithm. So again, we want to do n passes in the worst case scenario. So we would have the outer loop would be from I is equal to 0 to, or let's do I is equal to 1 to n. And then for the inner loop, since we want to iterate through each element within those n passes, it would be like from j is equal to 0 to n-1. So basically, if the array at index j plus 1 is less than the array value at index j, then we would want to swap the two. Now, one more thing we can make use of is the fact that we notice that the next greatest element was always getting in its right position with every new pass. And so with each pass, more of the end of the array was getting sorted. And so instead of doing from j is equal to 0 to n-1, we could do for j is equal to 0 to n minus I. So here I have a function called bubble sort, and the function takes in the array, and it also takes in an integer n, which represents the size of the array. So we're just going to follow the pseudocode. So for the n passes, we're going to do from int I is equal to 0 to from int I is equal to 1 to I is less than or equal to n, and then I plus plus. And then within each pass, we're iterating through all of the elements in the array. So we're going to do from int j is equal to 0 to j is less than n minus I. And the reason why we do n minus I is because, again, in every pass, the next greatest element is going to its right position. So then j plus plus. And then if the array at index j plus 1 is less than the array at index j, then we swap the elements. And then let me just print out the array so we can see if it actually works. And then let's run our code. Yeah, so here with our original array, unsorted array of 1, 30, 23, 59, 12, 24, and 19, we get the final answer of the sorted array with the numbers 1, 12, 19, 23, 24, 30, and 59. So that's how you code it in C++.